This is the same example I used in the previous video. So here also I'm finding the total current supplied by the source, and we can find the current passing through each element also. So in the previous video I transferred this delta into a y. So here what I'm going to do, I'm going to do the other delta into y, because the converting this delta into y is a lot easier and simpler, because the resistance, all the resistors are same. So if you find one branch resistance, that is going to be equal, and there is a trick for that. So the first important point, label the terminals A, B, C. Why am I labeling it? Because at the end, if you don't label it, you may get confused. Instead of connecting RA there, you may end up connecting right here. So that's the reason I'm labeling it. Okay, resistance between AB is RAB, resistance between BC, RBC, and RCA. Once I transfer this, I will end up with here is my RA. Sorry, that color is not showing properly. Let me use different color. Okay, this is my RA, and here is my RB and RC. So see, all the delta branch resistances are same. Okay, I'm going to draw the delta here. So this is RAB, RBC, RCA, A, B, C. Now my goal is finding RA, right? So to find RA, since every resistance is same, RA equal to RAB times RBC over RAB plus RBC plus RCA. If everything is same, here I have 15 ohms times 15 divided by 15 plus 15 plus 15. So 3 times 15. Okay, what happens? 15 get cancelled out. So RA equal to 15 divided by 3, which is 5 ohm. So every branch is same. So you will end up with RB equal to 15 divided by 3, which is 5 ohms. RC equal to 15 divided by 3, which is 5 ohm. So here is the trick. The trick is, if you have equal value resistors in delta, okay, here you have a delta, so same resistance R, and R. When we convert this into a Y, this resistance value, resistance and the Y value is going to be R divided by 3, R divided by 3, R divided by 3. Okay, so if each branch resistance is same in delta, then star values are just divided by 3, and it is valid for vice versa too. So if I have a Y connection R, when I convert this into delta, now this value becomes 3 times R. Remember, the delta value is always larger than the star values. So this must be 3R, this must be 3R. Okay. So it's a simple trick I want you to remember, so you can use it for bigger problems. I mean, it will save your time when you're solving them in the exam. Now going back to the original problem, so what we can do, what I did, I converted these 3 elements, the delta look elements, into a Y connection. So this is the circuit is going to look like. Okay, since each branch has the same value, don't need to worry too much about which branch is which, because every value is going to be the same. Now I can clearly see these 2 elements are in series. Same way these 2 elements are in series, 10 and 5. How do I know in series? Because at a node only 2 elements exist, and whatever current come in here, that current is going to divide. Let me say that's I1 and I2. Same I2 is passing through 10 and 5. Okay, so this circuit I can simply write it down as 25 plus 5, that is 30 ohm, and and here is 15 ohm, and this combination is in series with 5, so this is what we're going to have, 45 volt. Now 30 parallel with 15, for sure that value must be 10 ohms. Okay, 450 over 45, which is 10 ohm. So our R total, so you have 10 ohm resistance and then 5 ohm resistance, and you have 45 volt supply. Okay, so your I total must be 45 divided by 15, which is 3 ampere. So the current passing through this must be 3 ampere. This is 3 ampere. Now I can find the current passing through each resistor by using current division rule. So let me label this as I1, I2. So what is my I1? I1 equal to total current 3 amperes multiplied by opposite resistance over total resistance 30 plus 15, which is 45. So 45 over 45, that's 1 ampere. So out of this 3 ampere, 1 ampere is passing through this and 2 ampere is passing through this, and you can clearly see resistance is double, so double than the other one, so current is half of the other one. So from here I can tell this is 1 ampere and this is 2 ampere. Current passing through this is 2 ampere. Now I mean, from there you can find current in the 15 ohms, and I mean, by using the previous example we already found current in 15 ohm. In this 15 ohm, whatever the vertical branch, we can find the current in how are we going to find that? Yeah, we can find that current because we already know this is 1 ampere, this is 2 ampere, and we know the voltage there, okay, which is 45 volt. What is the voltage here? This voltage must be 45 minus 25 volt, because the voltage drop across this must be 25 volt. So here I have 45, so 25 volt drop, so I will end up with 20 volt at this point. Okay, I cleaned it a little bit so we can clearly see. So the voltage here must be 20 volt at point A. Now here, what is the voltage? I mean, the voltage drop here must be 10 times 2, which is 20 volt. So 45 minus 20, so here we have 25 volt. So the voltage at this point is 25 volt and the voltage here is 20 volt. So definitely current always flows from higher potential to lower potential. So the Ix equal to 25 minus 20 over 15. So 5 over 15, that's 1 over 3 ampere, which is 0.33 ampere. So from there I can see the current coming here must be 1, this is 0.33 ampere. So the current here must be 1.33 ampere and the current here must be 1.67 ampere, because 2 ampere is coming out of 2, 0.33 is going up, the remaining current is going through this branch. So if you look at the previous example, we found the current passing these two resistors is 1.66 ampere and 1.33 ampere. It's the same value. Okay, I'll stop this video here. In the next video I'll solve one more example, or maybe I'll solve the same example converting Y into delta. Thank you.